The provided diagram contains a directional discrepancy. Specifically, the west end of the port is illustrated above the north end. This is an error in directional representation. In a correctly oriented diagram or map, west should be located on the right-hand side. To properly understand and utilize diagrams, it is crucial that directional relationships are accurate and consistent with the established conventions. Consider a standard compass rose, which serves as a visual reference for direction. North is typically at the top, south at the bottom, east on the left, and west on the right. This arrangement is fundamental to navigation, map reading, and spatial understanding. When diagrams deviate from this standard, it can lead to confusion and misinterpretations. In the context of port operations, accurate directional information is essential for logistics, navigation, and safety. Incorrectly representing the west end above the north end could result in inefficient cargo handling, navigational errors, and potentially hazardous situations. Therefore, it is important to rectify such directional errors in diagrams to ensure clear and accurate communication. The implications of directional inaccuracies extend beyond port operations. In architectural drawings, engineering schematics, and geographical maps, precise directional information is critical for proper planning, construction, and orientation. For example, an architect might use a site plan to determine the optimal placement of a building based on solar orientation, prevailing winds, and access points. If the site plan contains directional errors, the building's placement could be compromised, leading to energy inefficiencies, structural problems, and accessibility issues. Similarly, in electrical schematics, directional arrows are used to indicate the flow of current. Incorrectly representing the direction of current flow could result in short circuits, equipment damage, and safety hazards. In geographical maps, directional information is fundamental to navigation, surveying, and resource management. Incorrectly representing directional relationships could lead to navigational errors, inaccurate land surveys, and mismanagement of natural resources. Therefore, it is essential to ensure that all diagrams, maps, and schematics adhere to established directional conventions. This includes using a consistent coordinate system, clearly labeling directional indicators, and verifying the accuracy of directional relationships. To further illustrate the importance of directional accuracy, consider the field of aviation. Pilots rely on navigational charts and instruments to determine their position, heading, and altitude. These charts and instruments are based on precise directional information. If the directional information is inaccurate, the pilot could become disoriented, lose their way, and potentially crash the aircraft. Therefore, aviation authorities have established strict standards for directional accuracy in navigational charts and instruments. These standards are constantly monitored and updated to ensure the safety of air travel. The principles of directional accuracy also apply to the field of robotics. Robots are often used in manufacturing, warehousing, and other industries to perform repetitive tasks. These robots rely on sensors and algorithms to navigate their environment and manipulate objects. If the robot's sensors are not properly calibrated, or if the robot's algorithms contain directional errors, the robot could become disoriented, collide with obstacles, and damage equipment. Therefore, robotic engineers must carefully consider directional accuracy when designing and programming robots. In summary, directional accuracy is a fundamental principle that applies to a wide range of fields, including port operations, architecture, engineering, geography, aviation, and robotics. It is essential to ensure that all diagrams, maps, and schematics adhere to established directional conventions to avoid confusion, misinterpretations, and potentially hazardous situations. The specific error in the diagram, the misplacement of west above north, violates this principle and should be corrected. Always double-check directional indications on any diagram or schematic.